Hello, this has been McGahee with McGahee Mathematics, and in this video we're going to talk about parallel perpendicular lines, see what the difference is between whether a set of lines is either parallel or perpendicular. And of course, if you could have the case of them being neither, if they're not parallel and not perpendicular. So let's just say we have two lines. We'll just call L1 would be a line with slope. We'll call it M1. And then another line, we'll call it L2 with a slope of M2. So just line 1 with slope 1, and then line 2 with slope 2. So we can say that line 1, L1, is parallel. We'll use the symbol. This means parallel, two vertical lines, to L2 if the slope M1 equals M2. So the only way two lines can be parallel is if they have the same slope. So that means that M1 equals M2. The slopes are equal. Now on the other hand, with perpendicular lines, we'll just say we're considering, of course, non-vertical lines. So any lines that look like this, that are of course not like this, straight, going straight up or down. We'll say that line 1, L1, is perpendicular. There's a symbol for perpendicular. It's perpendicular to line 2, L2, if, and the equation is a little different for perpendicular. You have to say that the M1 times M2, these two slopes multiply together, they have to equal -1. So that has to be true. That when you multiply the two slopes together, M1, M2, you always have to equal -1. So this means that in order to have a chance of being perpendicular, these slopes must have opposite signs. If they have, if the slopes are not parallel, if they're not equal, but they have the same sign where they're both positive, both negative, that they can't be perpendicular. So if you were to solve for, let's just say, M1 in this equation, you just divide by M2 to both sides. And of course, these are both non-zero slopes, so dividing by M2, we get M1 equals -1 over M2. So what does this equation say? M1 equals -1 over M2. This means that one slope is the negative reciprocal. So reciprocal is 1 over something. Negative reciprocal of the other. So like, for example, if you had a line with slope of, let's say, 2, and the other line has slope of -1/2, well, the reciprocal of 2 is 1/2, but then you also have the negative, so you got the negative reciprocal. So you know that these two lines would be perpendicular. And if you multiply 2 times -1/2, the 2's cancel, and so you're just left with -1. And according to that definition, we know that that would be perpendicular. Okay. So with parallel lines, the slopes have to be equal. They have to be exactly the same. And then with perpendicular, the slopes have to be negative reciprocals of each other, or their product has to equal -1. Okay. So let's take a look at example of a couple lines, and let's determine if they're parallel or perpendicular. So if you have, let's say y equals 2x minus 4 and y equals 2x or just 2x. Here you can compare the slopes, right? This is the number in front of x, like in the slope-intercept form equation in our last video. And you can see that both values for m, the slope, are 2. So since they're equal, we know that they are parallel. Okay, so another example we can look at is if we have, let's say you have x minus y equals 1. And if we have, let's say, x plus y equals 5. Now, in both of these equations, we don't have the y solved for, or y by itself, so we need to solve for y to get in the y equals mx plus b form. So we gotta isolate the variable y. So the best way to do this, there's a little trick, when you have some negative variable that you're trying to solve for, is you can bring this y over to the other side. If it's negative, it's going to turn positive, and then this 1, if it comes over to that side, that 1's going to become negative. So it's kind of like you're trading spots and then signs of the terms. So you're just going to get y equals, so that's positive y equals x, and then this will become minus 1. So it's kind of like a quick switcheroo. Y equals x minus 1. And now with this one, you can just subtract x to both sides. And then you get y by itself. So y equals, we'll put the x in front, so that'd be a negative x. And then that'll be plus 5. So you can write this as 5 minus x, that's okay. But I'm just trying to keep it consistent with the slope-intercept form, keeping the variable x first, and then the constant after that b value. So y equals negative x plus 5. So this is kind of tricky because there's no numbers really in front of x, so you wonder what the slope is. But if we go back, when you don't have a number in front of your variable, if you have x, you can see that that's equal to 1 times x, right? Because 1 times anything is that number. So 1x. So our slope for this line would be 1. And then for the negative x term, we can say that's equal to negative 1, right, times x. So we see that their slope for that line would be negative 1. So we already determined these slopes are not equal, so it can't be parallel. So maybe it's perpendicular. And so if we multiply the two slopes together, 1 times negative 1, we get negative 1, right? And so that fits the criteria for perpendicular line. So we can conclude that the line is, this set of lines is perpendicular. Okay, so perpendicular lines. So just a quick example of maybe a set of lines that are neither, would just be like y equals, um, let's say, 6x minus 9. And then if you have y equals negative, let's say 8x plus 13. So you can see right off that, the slopes 6 and negative 8, they're not equal. So you can take away parallel. That doesn't work. And then if you multiply these two together, 6 times negative 8 is negative 48. So that's not equal, of course, to negative 1. So it doesn't follow to be perpendicular either. So we can say this is neither. So this would be kind of like a set of, some people call it skew lines. They're not, they're neither parallel nor perpendicular. So this has been McGahee with McGahee Mathematics on parallel perpendicular lines. Just looking at a system of two linear equations, and we're going to learn, how to solve, a system of linear equations just by some different methods. There's actually 3 important methods that you'll learn how to solve a system of linear equations. So stay tuned for those lessons.